The next relationship that we're going to cover is generalization. The generalization association is the relationship between the base class that is named as a superclass or a parent and the specific class that is named as a subclass or a child. In UML diagrams, generalization association is also known as inheritance. The subclass is a particular case of the superclass, and it will inherit all the attributes and operations of the superclass, but it can also have its own additional attributes and operation. Generalization is also known as is kind of relationship, and it will be denoted by a solid line with an empty triangle pointing towards a superclass. In some cases, you will find that there is more than one subclass. All of them will be joined together, and the arrow will still point towards the class, which is the superclass or the base class or the parent. A subclass or a child will always inherit attributes, operations, and relationships from its superclass or its base class, which is also known as a parent. And take note, a subclass may have additional attributes and operations as well as additional relationships. However, we may not use the generalization relationship to model interface implementation. Let's look at this following example. The business rules state there are two kinds of students, namely undergraduate and postgraduate student, or it could be a student can either be an undergraduate or a postgraduate. The term student or the class student becomes our superclass or our parent or the base class, in which we have two kinds of students, either undergraduate or postgraduate. By just saying student, we have generalized, and therefore student as a superclass will have a subclass undergraduate and another subclass postgraduate. All of them linked together, and the empty triangle will always point towards the superclass or the base class, in this case the student. Another relationship is realization. This is a relationship that indicates that one class implements a behavior specified by another class, which could be an interface or a protocol. An interface can be realized by many classes. In this example, a linked list realizes an interface list. An array list realizes an interface list. White or an empty diamond will always point towards the interface or the protocol. It will always point towards the class that needs to be realized. Another relationship is dependency. A dependency means the relation between two or more classes in which a change in one may force changes in the other. However, it will always create a weaker relationship. Dependency indicates that one class depends on another. Let's look at this example. A course schedule depends on the class course. This means that any changes in the course class will force the course schedule class to change. Now we will move to the next relationship, which is aggregation. This is a special form of association that models a whole part relationship between an aggregate, which we also refer to as a whole, and its parts. Aggregation models is a part of relationship. In aggregation, the contained classes are never totally dependent on the life cycle of the container. That means the part or parts do not depend on the life cycle of the whole class. In this example, a car is a whole and a door is a part. A door is part of a car, or one can say a car has two too many doors. The lifespan of the door does not depend on the lifespan or life cycle of the car. That means you can reuse the door, meaning you can remove this door and go put it in another car. To draw this relationship in a diagram, a white diamond will always face towards the whole class, and the multiplicity here will always be 1 to 1. If we move to the other side, a house has one too many doors. A door is part of the house. A house as a whole does not own a part, meaning you can reuse this door, you can move this door and go put it in another house. Another example would be an employee and a department. An employee is part of the department, but the department is not part of the employee. That means even if an employee leaves the department will still be there. There is no full ownership. Let's move to the next example. Let's look at this example. A library has many books, at least one. A book is part of the library. A book can still exist even if the library is closed or is no longer functioning. That means the library will still remain functioning even if the book is removed from that library, and that makes the library a whole and the book a part. A white diamond will always point towards the whole, which is the library, and in this case the lifespan of the book does not depend on the lifespan of the library, and this side as a whole it will always be 1 to 1, and the multiplicity on the part will be based on the business rule